in action? Not yet. Come on. Ah, I know why. Huh? Oh, the me you're looking for?
That's what is in English?
What's an combination. You're both blind and he can see it in her eyes.
Come on, come on, come on.
That's 10? Alright. We're gonna be in the city center earlier though.
Oh yeah, I live in City Center.
Oh, okay, well if you want to join us, we're gonna go to the church first. And then no, not church.
Not sure.
The
Yeah, I'm
church.
atheist.
Don't worry, it's still let in.
No, but I'm like I don't want to get involved in religion yet.
You never know.
Wait till nearer to the exams.
Yeah, and I'll look for like every god in the world, you know. Allah, Jesus, Buddha, like power of the universe. Power of the universe.
And then we're gonna go have dinner and then head to the class.
Oh yeah. I'm
What
actually,
is wrong here? This is not power enough.
So after having a coffee with her, I'll call you guys.
By the way, the Turkish girls haven't confirmed yet.
That's fine.
I'll let you know by 1 o'clock. If not, then that's
Yeah, that's it. Yeah. We can still get her people. What did you have for your breakfast?
Porridge.
Oh.
But this box isn't turning on, which is a problem.
try the Arab way.
The what?
The Arab way.
What's that, hit it?
Yeah.
I don't think it's getting any electricity at all.
I know, but it's, yes, no, I figured that part. Is this the other end, or is this a different thing?
No.
Yeah, so...
Shall I sneak under the table?
No, it's okay, because I can see the phone here, it's just...
Alright.
Does this one have any lights in it? Oh, so you guys can order. This one should have a light.
Oh,
Do it quickly.
Why?
Because
Is it a break?
Ta-da!
What?
It's my hand.
The magic touch. Now we're talking. With the switches off.
Of calculator.
Calculators. Oh no, I have my calculator. I thought you said tacos. Because we're going to have tacos tonight. You're like, you guys can order your tacos.
But it says no.
Yeah. It's cheap and it's amazing. It's 3 minutes away from the academy. And the church is 8 minutes away from.
But it's not giving me any image.
Spicy Mexican food, get the idea. This is the bathroom. Yeah.
But that's this one. Yeah. So there's no input selected. This is connected. Wait. No. Wait. Yes! We're in business. Okay. So last time we were looking at one linear and one quadratic, that's it, yeah. So I think the next topic is inequalities.
Yeah.
Alright, so let's have a look at those. linear. Hey, come on.
Linear and quadratic inequalities.
Yeah. So we know the word linear. That's like mx plus c. And we know the word quadratic. That's like ax squared plus bx plus c. Some people may not know this word inequality. So inequality are these things. So we're going to look at linear and quadratic inequalities. Now, the linear ones are very easy to do. It's only the quadratic ones are a little bit tricky. But just before we start the linear and the quadratic ones, just a little bit of notation, okay? So the first one here, set or. Does anybody know what's in this set? I'm sure somebody does. Yeah, this is all real numbers. Basically, it's everything between minus infinity and infinity. Okay, so is it here? Is it that you need?
No, the sign of real numbers. The sign.
The sign minus.
Yeah, the R. Yes,
Yeah.
the sign.
This or, it's a special font called Blackboard font. It's not the same as this or. It's a different font. The next one is this one. Does anyone know this one?
Irrational
Not quite
number.
this one.
Do we need to know all of this?
Which one?
Everything, like these notations, do we need to know them?
What do you think? I'll give you a clue. I'm doing it in class. I knew you were smart from day one. Now, does anyone know this one? Does anyone know it? No? Okay, this one, it's called the integers, and it's the numbers like -2, -1, 0, 1, 2, etc., 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 from minus infinity to plus infinity. So these are called the integers. Okay, you need to write this down since nobody told me it, so make sure you have it, please. We'll do a couple more.
Wait, so what was the first one?
Real numbers, which is basically everything from minus to plus infinity. Actually, I still need the projector moved a bit to the left. Make yourself useful and move that a bit to the left, could you please?
Thank you. I finally found my.
We found some use for you. Yes.
Yes, thank
Yes.
you. How productive.
Very productive. Now don't kill yourself. Alright. Yes. Perfect.
Perfect.
So you just said perfect and then decided to continue. Yeah. Okay. Next one. This one, Q. Does anyone know this one?
Can I ask you a silly question?
Yeah.
Does that line in the cube, is it necessary?
Yeah, because it is actually a different font. It's called Blackboard font. It's what is most commonly used for these sets. So,
Quotient.
no, not quotient. So, kind of is. Now, if you didn't write it in the exam, it's no big deal. But I'm just saying, if you're going to like look up books or notes or videos online, I'd expected it to look like this. Okay, does anyone know the Q? No?
Rational number.
Rational numbers, but what are rational numbers?
Like
Numbers you can divide.
3 over
Yeah, we can be
2.
a bit more precise though than that.
Not decimal, not fraction. It can be written as a fraction.
Yeah, but
Not irrational.
more
number.
precise than that.
Oh.
Perfect.
Yes.
Not irrational.
Rational numbers are numbers which are rational. Yes. Rational numbers are numbers that can be written as P over Q, which I know you said, but it's important also to state that P and Q are both integers, and of course Q is not 0. So some examples, you know, like 1 over 3, 5, minus 1 over 2, they're all rational numbers. What's an example of a number that's not a rational number?
I.
Definitely, but that's something a bit simpler. Root 2 is the simplest example, because it's impossible to write it as a fraction. Okay, the next one now. No. This one.
Natural number.
Natural numbers. Natural numbers. And what are those?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Include 0 or not?
No. Positive. Positive numbers.
In fact, it is not clear whether or not to include 0. Some books include 0. Some books do not include 0. It depends actually on the book. So what's often done to prevent any confusion, when you want to include 0, you write a little 0 on the top here, like this. And this means you include the 0. If you don't want to include the 0, you put a little star on the top, like this. Come on. Now, again, it's also different for different exams. So, I can't remember what they use in the A levels. Has anyone?
The A level, there is no 0.
Yeah.
There's no zeros?
No zero.
A level natural set. You said no 0?
Yeah.
Yeah. I just switch screens for a sec. So like here, for example, on this website, they include 0 in the natural numbers, you see? Any other ones where we could see the numbers? So like, let's go to Maths World, see. And if we go to this website, they don't include the 0. So it's actually not clear whether or not to include the 0. It depends on the author and the book. So for me, to prevent any confusion, we use this notation, which is common notation. People know what these mean. So this one is a little bit unclear, but these two are very clear. This means include the 0, and this means don't include the 0. Okay, can I scroll down? Yeah? Okay. So these are the common ones, or, Z, Q, and N. There are a few more. And just before we go on, there's also some set notation I want to show you. So, if you have something like this, A to B, with square brackets, this means all the numbers from A to B, including A and B. So for example, if I had 1 to 10, is 2 in this?
Yes.
Yeah.
2.5 in it?
Yes.
Yeah.
Minus 1?
No.
No. Pi?
Yeah.
Yeah. This is called a closed set. Now, I don't know if anybody's seen this notation before in school with the square brackets. Maybe some people have. No, you've seen it before? Yeah, yes. Have you seen it before? No. Have you seen this one before? Yeah. So just write this down, especially if you haven't seen it before. It's called a closed set, or to be more precise, closed at both ends. What would this mean here?
Union. Everything including this and this.
Yeah, so like this one here are all the numbers from 1 to 10, and then we skip some and go from 100 to 102. And we draw it like this. So for example, 11.
No.
No, not in it. Yeah. Okay, can I scroll down? Yeah. Now on to open sets. These are all the numbers between A and B, not including A and B. So not including A and B. So for example, here if I do 1 to 10 again, 1 is not in this, 2 is in this, 2.01 is in it, 10 is not in it. And we can draw this on the number line with an open circle like this. This is 1 to 10. So this is called an open at both ends set. And if you're wondering, can you mix them? You can. So if I had something like this, 1, 3, that would be all the numbers which are 1 or bigger, but less than 3, and not equal to 3. What would this be? What's this? Yeah, which is called...
R.
Yeah. In the exam, sometimes they want the answer using this notation, and sometimes they are happy just to write it like this. So the key word you want to look for in the question is set, because these are called sets. Sets. Now,
What does the T stand for? The T.
T?
It's not a T.
Where's the T?
This before the R.
Equals?
No, up 10, and then you have a slash on the T.
Oh, that's not actually a T. I'm not drawing that very clearly. It's actually this symbol, which means element of. And then this one here is not an element. So, for example, come in, yes. Quick, come on, sit down. Stephen is an element of this class, for example.
Stephen is not an element of this class.
Well, right now I am. Nader here? No, at the moment Nader's not a member of this class. He's a physics student, so... Okay. Just write this one down. Now, a little interesting thing about the word set. In English it has, I think, as far as I know, it's the word with like the most definitions. So if you go to a dictionary and try to look up the word set, you'll get about lots of definitions for the word set. So only one of these is for the maths meaning. Let's see. Where is it gone? Hang on. Ah. Yeah. Definition number 3. So anyways, just to say, listen, English. I'm teaching you some English right now. The word set is used so many different ways in English. Okay, this is not the only meaning. There's like 50 meanings of the word set. You can use it as a noun, a verb. It could be used so many ways. Right now, we're using it to mean these. Okay? But just so you know, that's not the only meaning. You can use it as a verb. Does anyone know the meaning of it as a verb? Yeah, sorry. The meaning of the word set is to set something. Yes, correct.
Set the table. I have a question.
Yes.
If they ask you to set like let's say like solve each of the following and draw the number of lines to display the solution given that x is real, and do we have to put that element?
It depends on the question. I'll talk more about that when we do some examples now. So look, set, could also mean make. You could also put a prefix in front of it, like reset. Preset? Reset? Yes.
Does that make sense? Reset?
Preset, yeah. Preset makes sense. Reset makes sense. Set makes sense. Yes. I can use it as an adjective. I can use it as a noun and a verb. There's lots of different meanings for it. Okay, let's have a look at some examples now. Can I scroll down? Yes. Right. Solve something like this. And I tell you x is real. And I want you to draw the answer as well. Okay, so just write this down and we'll do it.
Draw it on a graph or on a number line?
Number line. Now, let's do this one. The nice thing is, these inequalities, they work the same way as equations. There's only one exception. Yeah. If you have a less than b, you can do, like let's say a plus c less than b. You can do things like this, a less than b minus c. You can multiply both sides by a number, like say 2. 2a plus c is less than 2b. The only time it's different is when you multiply or divide by minus. So for example, if a is less than b, we say minus a is bigger than minus b. So the minus flips it around. Just be careful. Now you might be thinking, why is that? Well, if you think about it on a number line, here's 2 and here's 3. Here's minus 2 and here's minus 3. 2 is smaller than 3, right?
Yeah.
But if I flip them, minus 2 and minus 3, it's the opposite now. Now minus 2 is the bigger one and minus 3 is the smaller one. So it gets turned around. So when you flip the signs, you also flip the inequality. Just remember that.
Can we make it equal to 0? That's that point. Can we move a next to b?
Oh yeah. So you could also say like a plus c minus b less than 0. Yeah. Question, sorry? Oh please, no, ask me a question. No, you sure? Alright. Okay, can I go back to the question? Yeah. Right, so what I'll do first is I'll take this x to the left. Yeah, minus 6x less than or equal to 6. So x bigger than or equal to 6 over minus 6. So that's bigger than or equal to 1. Minus 1. Not t. So on a number line, it would be, if there's 0, 1, minus 1, it would be from here, including minus 1, all the way to infinity. This would be the answer. Okay, this is our first example. Write this down. Of course, they get more difficult. I'll give you one like this to try, and then we'll move on to something a little bit more difficult. This type is too easy for the exam. It's only a basic one to start with. But I'll just give you one to warm up with. So it's the same. I want you to solve 6x plus 8 less than or equal to 8x minus 6.
Like in the exam, can we just like put the answers like that? Like x is bigger than -1.
If they don't specify how they want the answer, then yes.
So,
But we'll get to one where they don't want it this way. Yeah.
so
Scroll up. I'll zoom out. Yeah, go ahead.
when
Jim.
there's like a word set, that means you
As a noun.
yeah now then you'll have to put a like
They would want it like sorry. What am I doing? Sorry. -1 to infinity.
oh that like that.
Like that, yeah. But we'll get to that in a moment.
I have a question.
Yes.
Can we not keep the infinity in a closed set?
No, because infinity is not an answer. Yeah. Okay, we'll look at this one now. So we have here 6x minus 8x less than or equal to -8 minus 6, minus 2x less than or equal to -14, x bigger than or equal to 7. On a number line? Yeah, from from 7 to infinity. Okay. Let me give you another one to try. A little bit different now. Want to see how you do. -11 is less than or equal to -4x plus 5 is less than or equal to 13. And x is a natural number not including 0.
What's the difference between like etched looking thing and like a round looking?
Are we talking about this?
No, about like when you were writing an infinity.
Yeah.
Like, at that time, like
The bracket?
yeah, the bracket, like this and like something had like a S, yeah, like that.
Oh, this one.
No, like little bit S.
Yeah. Like this?
Yes. What's the difference?
This can't happen. This means you include infinity in the answer, and this one means you don't include it.
Oh, okay.
So that's the difference, if you remember earlier, between open and closed. Closed means included, open means don't include it.
Okay.
You have an answer, Lee? Could you write it down? It'll make me feel better. Thank you. Okay. Let's have a look here. There are two ways to do this. I'm going to show you both ways. The first way, which I'm sure some people did, is to write this as minus 11 less than or equal to minus 4x plus 5, and then minus 4x plus 5 less than or equal to 13. Yeah. You can solve each one separately. So the first one, you'll get 4x less than or equal to 16, and the second one, what would you get? Let's see, minus 4x less than or equal to 8. So here you have x less than or equal to 4, x bigger than or equal to minus 2. So if you think about the number line, we're looking at minus 2 to 4. Minus 1, 0, 1, 2, 3. However, x must be a natural number. So we can't use minus 2 or minus 1 or 0. We can only use here. So the answer can only be these 4 numbers. Not when I write it like this with the star.
Oh, okay.
There is another way to do it. Yeah. Okay, continue. The other way to do it, minus 5 from everything. So minus 11 minus 5 less than or equal to minus 4x, and then 5 minus 5 is gone, and then 13 minus 5. So you get minus 16 less than or equal to minus 4x less than or equal to 8, and then I should divide everything by minus 4. So this becomes 4, this becomes minus 2, but these get flipped. So in other words, x must be bigger than minus 2, but smaller than 4. That's the same result as this. So we get the same answer. X is also a natural number, so the answer is 1, 2, 3, and 4. You have two methods. This one I prefer, but you can do it both ways. Did anybody do it this way? Yeah?
Yeah.
Yeah, and some people did it this way? Yeah?
Yeah.
This is the way you did it? Yeah. Okay, let me give you one now that's like this to try, just in case some people didn't get it, and then we'll go on to quadratics. Minus 11 less than or equal to minus 2x minus 17 less than or equal to 5, and x is an integer. Try this. Leave Lee alone and do the question. Okay, you should be finishing it now. They're not that long to do.
When do we flip the thing?
When you multiply or divide by a negative, which will happen in this one.
So like the minus 4, although we're dividing them over minus 4, we still flip it?
Yeah, yeah. Okay. I should add 17 to everything. So I get 6 minus 2x, what's that, 22? And then divide everything by minus 6. What am I doing? Sorry, minus 2. That's minus 3 flipped x flipped minus 11. So basically I'm saying x is from minus 11 to minus 3. So the answer is minus 11, minus 10, minus 9, etc. minus 3. All the numbers from here to minus 3. Minus 11, 10, 9, 8, 7, 6, 5, 4, 3. Okay, we'll go on to quadratics now. Please write this one down. Yes. Yes. Yeah. I know I wouldn't want to sit beside him either.
Oh no.
No. No. Lee, what are you doing? What? You're sitting right in front of me, I can see. Okay, can I go on to the next example now?
Yeah.
Yep. So let's have a look at quadratics. We'll say 21x squared plus 32x plus 12 greater than or equal to 0. So for these ones, we kind of have to factorize. Now there's two ways of doing it. I'm just going to show you both ways, and you do whichever one you prefer in the exam. So this is the first way to do it. No. Is this going to do it? 21,
Yeah.
12. It is 18 and 14. 32. Yeah. So the first way you do it, the first part is to factorize, and then you think about what you need to have here with the signs. So we want it to be greater than or equal to 0. There's two ways that could happen. That this is positive and this is positive, or this is negative and this one is negative. That's the only way the result can be a positive. If each are positive or each are negative. So let's look at the two situations separately. And there's a big or between them. 7x plus 6 is positive and 3x plus 2 is positive, or 7x plus 6 is negative and 3x plus 2 is negative. So if I solve this, I get x is bigger than minus 6 over 7 and x is bigger than minus 2 over 3. Now think very carefully about your conjunctions here. This is minus 6 over 7. This one here, minus 2 over 3. This one here, 0. You want, now listen carefully, you want x to be bigger than minus 6 over 7 and bigger than minus 2 over 3. And the and is very important there. The only way x can be bigger than minus 6 over 7 and bigger than minus 2 over 3, the only way that that can happen is if x is bigger than minus 2 over 3. That's the only way both can be true. Or, and then here we get x must be smaller than minus 6 over 7 and x must be smaller than minus 2 over 3. Draw the number line again. Minus 6 over 7, minus 2 over 3. X must be smaller than minus 6 over 7 and x must be smaller than minus 2 over 3. The only way we can have both is if x is smaller than 6 over 7. And this is the answer. If you want to write the answer as a set, it must be smaller than minus 6 over 7. So that's minus infinity to minus 6 over 7. And then we also have x bigger than minus 2 over 3. Which part exactly? Here?
Yeah, didn't you say why is the blue over minus 2 over?
That's the blue is for this one. The red is for this one.
Yeah.
Here the red is for this one, and yes, the blue is for this one.
And why is it different?
What do you mean, why is it different?
Like, aren't they supposed to give us the same answer?
No.
Oh.
Because these are, here I'm saying something different to what I'm saying here. Here I'm saying x is bigger than this, and here I'm saying x is smaller than this. And the two halves are linked by the word or. Now, I'll let you write this down. Listen. I'll let you write this down in a second, but I just really want to stress the importance of and or here, okay? So you could say x equals 1 or x equals 2, but you can never say x equals 1 and x equals 2. Why? You can say x equals boy or x equals girl. That is, x is a boy or a girl. But you cannot say that x equals boy and also x equals girl, with some exceptions, of course. It's important that you, now do it, keep it good. It's important that you appreciate the difference when to use or and. Okay? So, or you're saying it's both could be true, whereas and both must be true. So this one here is a must be true, both of them, whereas this one is more like a could. It could be 1, it could be 2. Must be 1 and must be 2. So please take care with and or. Okay, write this one down and then I'll give you one to try like this. Write this down and then I'll show you the other way to do it.
I want to ask you.
Yes. I'll wait later.
It's about the same question.
Yeah, what is it? Say it.
What I used to do is...
Wait! I said there's another way to do it. Wait until you see the other way. Because as far as you know, that's what you're just about to see. Then you don't have to ask me, and then we save so much time. Okay. Can I go on to the other method?
Yeah.
Okay. So I'll do the same question, but the other method. What was the question? It was 21x squared. Okay. 21x squared plus 32x plus 12 bigger than or equal to 0. So again, you factorize. What is that? 6x plus, no, 7x plus 6, 3x plus 2. Here's the different part. Watch carefully. It's much quicker this way. You draw a very quick graph. Here you put, now you see you're nodding. Is this the way you did it? It's a good thing you were quiet. So, right, here we have minus, hang on, this is 6 over 7. Yeah, minus 2 over 3 and minus 6 over 7. So a very, very, very quick graph is like this. Then what you do, if it's bigger than 0, you highlight the upper part. If it's smaller than 0, you highlight the part under. So in this case, is the top or the bottom I highlight? The top. You highlight this, and then you just shade it in, and it's this part that you want, and this part here that you want. So that's minus infinity to minus 6 over 7, or minus 2 over 3 to infinity. But if you want, you can write the answer like this, x less than minus 6 over 7, or x bigger than minus 2 over 3. You can give the answer both ways, but if they say set in the question, it means they probably want it this way. There is a third way to do it, but these two, I kind of want everybody to do it this way because it's the quickest and easiest way to do it. But some people, they're strange, I don't know, but some people prefer doing it this way. That's their business. I would like you to do it this way. Let me give you a quadratic to try now. Try this one. Minus 7x squared minus 41x minus 63 less than or equal to minus x squared. What should you do before you start to simplify this?
The sign.
Well, could get rid of the minus, but something else more important. Yeah, it's important that you move this to the left. So that, bring it to the left. Okay, try this one for a minute. Okay, we got this finished. Finished. Let's have a look. So, first, we need to take this over here, and that's x squared minus 7x squared minus 41x minus 63 less than or equal to 0. So minus 6x squared minus 41x minus 63 less than or equal to 0. 6x squared plus 41x plus 63 greater than or equal to 0. What are the two solutions here?
Negative 7 over 3.
Actually, yeah. Actually, I think factorize, but something here.
We should draw the original graph that is negative.
Nope, we don't have to. We get the same answer.
Okay.
Trust me. I had someone ask me the same thing last year, and I had to show him that you get the same answer by doing it both ways.
Yeah, you changed the sign so you did the same.
Yeah. I'm glad you're more agreeable than the student last year. He insisted on seeing it because he didn't believe me.
I have commented.
Right, actually, let me just show you something here if I just get it. I can find it. Just a sec.
You changed the negative sign. Positive?
No.
One sec.
Okay, then what's the graph of this one? Is it like this? Or is it like this? Yeah, we draw this one and draw this one.
That's not working.
No, the
Ah.
the M0, so it's this one. This M0 is a number, so it's a number.
No, it's not working. Alright, doesn't matter. I'll show you later. Okay, so what were the two answers here?
Negative 7 over 3 and negative 9 over 2.
Minus 9 over 2 and then minus 7 over 3.
Yeah.
Yeah. And it's going to be this shape. And do we want above or below?
Above.
Above, so it's here and here. So your answer is minus infinity to minus 9 over 2 and then 7 over 3 to infinity. Okay. Can I scroll down to the next one? So one more type to do. I'll let you try it, see what you can do. Yeah?
Can you write
The set with this inequality. Yeah. So the other way you can write the answer is x less than or equal to minus 9 over 2 or x greater than or equal to minus 7 over 3. Yeah. Okay. Yeah, ask me. That's what I'm here for.
It's a long question. Maybe
Yeah.
to the
Is it about this?
It's
Yeah.
the same question, yeah.
yeah. It's the same. Why do you change the sign?
Here to here?
Divided by negative 1.
Oh, sorry, here to here.
Yeah.
Yeah, I multiplied everything by minus 1.
So.
So this becomes plus 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 0.
So
You
can
factorize.
I just factorize.
You factorized here?
Yeah.
Yeah, that's fine. But just take care when you draw the graph, it'll be upside down because it's a minus.
And it's not in between. The answer is not in between.
The answer is
But you're less than,
Yeah.
so that would be under. Yes?
Okay.
Yeah. Okay. Right, next one.
So we could get different answers?
No, you should get the same answer, but you can do it a different way. You You should get the same answer. Guys, just take care. Alright, I'll write it down. Some people at this line factorized. So if you did it at this step instead of the next step, you get the same answer. Watch. What were your two answers here? When you solve this, you still get minus 9 over 2 and minus 7 over 3. But what's different, because it's minus here, it's this shape for you. But because it's less than, you want the piece under. So you still get the same answer as I got here. So it doesn't matter if you multiply it by minus 1 or not. You get the same answer. Yeah? Okay. It's tricky, I know, but practice. Nearly perfect, at least. It's good enough for the exam.
Is everything above that point, or is it to the x-axis?
Yeah, here it's everything here and everything here. And this one it's everything here and everything here. Everything, I kind of colored this part in. Not that I need to, I just really care about the axis. Is that what you're asking me?
Oh yeah, okay. So all we care about is the x-axis.
Yes. Yeah. Okay. Here's another one to try. This is the hardest one now. So first let's just say x is a natural number including 0. And we have 71 less than or equal to 2x squared plus 20x plus 49 less than or equal to 97. Now see what you can do with that. Then I'll do it in a minute. Try. See what you discover. You will grow as a person by the end of it.
Can we move the number from one side to the other and make it a 0 for only one?
Only one at a time, yeah.
So we only change the sign if we are multiplying or dividing by negative.
Yeah, that's the only time. Some people have an answer?
Yes.
Yeah. You have an answer.
Mhm.
Could it be right?
Maybe.
Could be. We'll see. 1 more minute and then I'm going to do it. We're missing Nader and Fuan and anybody else? Lee! What's wrong? Are you finished? Finished? Is it right?
Maybe I'm wrong.
Ah. Did you order a calculator yet? Did you? Right, let's have a look. Okay. So, watch carefully because this one is more difficult than the last one. So, we can only do this by splitting it into 2. We have to say 71 less than or equal to 2x squared plus 20x plus 49. So 2x squared plus 20x, what's that, minus 22?
Yeah.
Bigger than or equal to 0. And then here we have 2x squared plus 20x plus 49 less than or equal to 97. So that's 2x squared plus 20x, 48 is it, thank you, minus 48? Less than or equal to 0. X squared plus 10x minus 11. X squared plus, where my x go? 10x minus 11. X squared plus 10x minus 24. Now, what goes between these two? Is it and or? And. Because we want all of this to be true. So it's an and between them. Now, we know how to solve these. We just did them. What are the two solutions here? 11 and 1. 1 and minus 11?
Yeah.
Is it?
Yeah.
Minus 1.
The roots? Is that right? Yeah. And then here it's a 12 and a 2. 12.
Like, no.
No.
Plus 12.
Plus-
Negative 12.
12 and minus 2.
Negative 12.
Negative 12 and
Plus 2.
Minus 12 and then 2 here.
Yeah.
Okay. So this one goes like this. This one here goes like this. Here we want less than. So that's this piece. Under. And here we have more than. So that's this piece over. So here x is less than or equal to minus 11, or x is bigger than or equal to 1, and x is bigger than minus 12, or x is smaller than 2. Now, really here actually, it's an and rather than. Sorry, I don't. No, ignore. Pretend you didn't see that last line. Right, here we write the answer like this. X is between minus 12 and 2. It's from here to here, whereas this one is from here out to infinity and here out to infinity. Okay. Now, that's not the final answer. That's not the final answer because we need to put these together because we have an and in between them. So that's the next part. Can I draw the number line now? So, here to here, infinity, minus infinity, and here we have minus 12, minus 11, 0 in the middle, we'll say. We need a 1 and a 2, don't we? Yeah. We'll just put them here, 1 and 2. Okay, so just write this down. The next part you need to focus. Can I do the next part now? Yeah. Now, look at this one. X must be between minus 12 and 2. So X is from here to here. So I'll just put that in red. And X must be less than minus 11, which I'll put in blue, or bigger than 1. Now, because of the and, we need the part of the number line where both are true, because it's an and. So there's only two places where we can have the and. Here, they're both true, and here, they're both true. So we can put these together to make X is between minus 12 and minus 11, or X is between 1 and 2. But that's not finished yet, because at the very start I said X is a natural number including 0. So can we use this answer? No. So we reject this. X must be between 1 and 2, including 1 and 2, and a natural number. What are the natural numbers between 1 and 2? 1 and 2. So after all of that, the answer is X is 1 or 2. Very difficult. Most difficult. In fact, too difficult for the exam in my opinion. But if you can do this, you can do anything that happens in the exam. I like to make the questions a little bit harder in class than in the exam, so that when it comes to the exam, it will feel a little bit easier. It'd be worse if I did it the other way, made the class questions easier than the exam. That means the exam will feel harder than normal. Okay. So I'll give you a few minutes to try some of these. Let's see, we'll do... C, D, E in each. Okay, you can start them now for a few minutes. And don't worry, that was the end of the first chapter, so we'll start at the next chapter in a few minutes, which starts off an easy topic. Yeah, C, D, E in each of them, yeah. Sorry. That's better. Lee? Is that Moodle? It's not. I can see from here it's not, because I can see profile pictures, okay? That's not Moodle. Come on. Just remember, teacher knows all and sees all. Yes. It's the best view to take in the classroom.